Mommy, you never hinted me. A boy, form leader. So that's the first condition. Two, the angle of incidence, in the denser medium must be greater than the critical angle of the material. Critical angle of the material. So these are the two main conditions necessary for TIR, total internal reflection, to occur. Please, is there any question? Is there any question? All right. Now, so the moment total internal reflection occurs, the reflected ray, which before then was weaker, will now be seen to be brighter or stronger, brighter this time when total internal reflection occurs. This is because the refracted ray will just add to the reflected ray. And so the reflected ray, which before was weaker, will now be brighter. And don't forget, there wouldn't be any refracted ray. We'll just have all the incident ray being reflected, and still angle of incidence will be equal to angle of refraction. So if it was increased to 45, then we'll have this to be 45 as well. Please give me a minute to pick this call and get back to you. Okay, very important. So that is total internal reflection. We'll come to the applications, how it is used. But let's go through the theory. Now, different materials have their own critical angles. So if, assuming the dense medium is glass, if the dense medium is glass and this is air, excuse me, I'm coming, let me quickly. All right. So different materials have their own critical angles. So if you want total internal reflection to occur, then the prerequisite is that you must know the critical angle of that particular material. Glass, for instance, the critical angle of glass is around 42 degrees. Meaning that if this is glass air and I incident that that the ray is incidented at an angle of 42 degrees, you have the refracted ray just lying on the boundary between glass and air. 90. But the moment you go beyond 42 degrees, that is when you will experience total internal reflection. All the incidents will be reflected.
Let's go to where Alida sends us to.
Leonard, mute yourself. Right. So if you want to cause total internal reflection in a material, then you must know its critical angle. Please, class, are you okay? So that's a requirement. You must know, for total internal reflection to occur, you must first know the critical angle of the material. Then you go beyond the critical angle a little bit to cause total internal reflection to occur. So what we are going to do from now is that if you have A, B, C material, how do you determine its critical angle so that you can use that to create or cause total internal reflection to occur in a material? So that's the next thing to do. Now we have two different materials. Hey, Leonard Alba. This is a dense material of refractive index mu D. This is a less dense material of refractive index mu L. D for dense, L for less dense. Let's assume that the critical angle of the material is C. Okay. Now we learned that for two composite materials, meaning two materials that are joined together, the product of the refractive index and the sign of the angle of incidence in it. So the refractive index D times sign of the angle of incidence, which is C, must be equal to the product of the refractive index of the other material and the sign of the angle of refraction. And what is this angle of refraction? This is 90 degrees. Okay. Now, what we are looking for is to determine C. So sine of C is equal to, if we make sine C the subject, we have n of L over n of D times sine 90. Sine 90 is equal to 1. Sine 90 is equal to 1. Therefore, C is equal to the sine inverse of the refractive index of the less dense, the ratio of the refractive index of the less dense, and then the refractive index of the more dense material. Now, if the less dense material is air, if the less dense material is A, because the refractive index of A is equal to 1, the critical angle becomes sine inverse of 1 over the absolute refractive index of the more dense material. This is how to calculate for the critical angle of a material. So example, if I have two media, glass, air, and the light is coming from glass to air, at the critical angle, the refracted ray, yes, will be 90. The angle of refraction. So if I want to determine the critical angle of the glass, then C will be equal to the sine inverse of 1 over the absolute refractive index of glass, which is 1.5. Help me divide 1 by 1.5 and then take the sine inverse and then give me the value of C. Please do that for me quickly. Sine inverse of 1 over 1.5 in the bracket. Yes, what have you had?
41.81.
41.81. So approximately 42, as I said. The refractive index of water is 1.33. Use this to help me calculate the critical angle of water if light is moving from water to air. So help me use this information to calculate for the critical angle of water if light is moving from water to air. Yes, what have you had for that? Oh, class, are you there?
48.75.
So it means when light is moving from water to air, then the critical angle, the angle by which the angle of refraction will just lie on the boundary between water and air is 48, okay, point something. So you see, the essence of knowing the critical angle is that by knowing the critical angle, you can easily cause total internal reflection, because the condition for formation of total internal reflection is that the angle of incidence must be greater than the critical angle of the material. So when you know, you would be able to figure out the angle to go so that you cause total internal reflection. So if the material has to be a more dense to air, then note that sine C is equal to 1 over the absolute refractive index of the dense medium. Okay. Then C is equal to the sine inverse of 1 on the absolute. That is if less dense medium is air, so we use these two equations when the less dense medium is air. If less dense medium is not air, then sine C is equal to the absolute refractive index of the less dense medium divided by the absolute refractive index of the dense medium. And C will be equal to sine inverse of NL over ND. So these two relations also apply if the less dense medium is not air. Example, supposing you are given two media, glass and water. You know, earlier I wrote it as water and glass, and then I quickly changed it to glass and water. And I did this because the condition for total internal reflection to occur is that light must travel from a more dense medium to a less dense medium. So I cannot have water glass. I must have glass water so that the light is propagated from the denser medium. So if we have a situation of this sort, and I'm asked to calculate for the critical angle of the glass, then I must take the sine inverse of the absolute refractive index of water, the less dense medium water, divided by the absolute refractive index of glass. So in this particular instance, the critical angle will be equal to sine inverse of the absolute refractive index of water is 1.33 divided by 1.50. Please calculate this for me. If we have this situation, what then will be the critical angle of the glass? So divide 1.33 by 1.50 and take the sine inverse of it for me. Come again.
62.46.
Oh, okay. So that is it. So you must know how the situation is. Okay. If the light is moving from what to what, in order to use this relation. Please, is there any question? Is there any question? Okay, so this is the theory of total internal reflection. Let's look at applications. How is it used in everyday life activities or in the scientific world? Applications of total internal reflection. Do I clean the board?
Yes, please.
Okay. Now, TIR is applied so much in the scientific world. It is applied in a telecommunication industries. It is also applied in the medical field. And then everyday, okay, science phenomenon. Let's look at how it is applied in the telecommunication industry. Then we look at how it is used in the medical fields. You see, before, if you want to communicate with somebody, especially somebody in abroad or outside Ghana, then you must dial with your phone. Your call will be picked by the poles within the community, MTN, Vodafone, okay, and other networks. Then it will be sent to their head office in Accra. The head offices in Accra also have outside Ghana satellite or dish. This is the gateway for international calls is located, the satellite, the very big dish is located in Kuntunsi in Accra, along Nsawam Road. So all calls moving outside Ghana will be picked by the satellite and then will be given to a satellite in space. Okay, the international satellite in space. Then the foreign call would be given to the main transmission or switching office in US. Then the US office will look for the destination of the call. And this explains the reason why then calls to even Togo is more expensive than calls to US and other European countries. This is because, you see, Togo is just here, Burkina is up here, Cote d'Ivoire is just here. But if you want to call somebody in these three mentioned countries, interestingly, your call must go to US before. Okay. It is similar to you wanting to go to maybe Tamale, and your location, there is no direct transport. So you need to go somewhere, pick a car from your location to somewhere, then you pick a car from that somewhere to Tamale. So it will add up to your cost. So because Africa, we don't have our own communication satellite, we hire the international satellite. So a call going to Togo, which is here, must be given a car to go to US before it comes from US to Togo. And so it will add up to the cost. And so even before, the credit to talk to somebody in Togo for 1 minute, you would use that to talk to somebody in US for a very long time. Meanwhile, Togo is just here. Just is the reason. But now, to reduce costs, the telcos, instead of using the satellites, they lay cables from Ghana straight to England or UK. The telcos can even have cables which is laid straight to US. So in that case, if you want to talk to somebody in US, your call would just go straight and wouldn't go to space whatever before. Okay, and that efficiency and then cost effectiveness has been made possible due to using what we call fiber cables. Fiber cable. So we have fiber optic, either fiber or fiber optic cable. The fiber cables operate on the principle of total internal reflection. So fiber cables operate on the principle of total internal reflection, TIR. How does the fiber cable itself look like? It is a very thin glass tube or fiber. Very, very thin glass fiber. Very, very thin, small glass tube or fiber, which is used in transmitting large volume of voices or data. Once it is glass, you see the information that is being transmitted is sent in the form of light. And under TIR, we know that by knowing the critical angle of the glass, you must exceed the critical angle a little bit, and the light will be internally reflected. So when the incident voice or data calls is incidented in such a way that the angle of incident, okay, is greater than the critical angle of the glass fiber, total internal reflection occurs in there, and the information can easily be sent from the source to the destination. That is why we are saying that this operates on the principle of total internal reflection. Whatever is to be sent, whether voice calls or data, is bundled in the form of light, and the incidental light is incidented at an angle greater than the critical angle of the fiberglass, and total internal reflection will just take it, move it on and on and on at a fast speed and minimal losses. Amia, your hand was up.
Please, why is the call being bundled into light rays? And if it's bundled into a light ray, how is it unbundled again for you to talk?
Maria, do not worry yourself with the modulation and demodulation. Leave that to the telcos. Okay. As for how it happens, leave it to them. But because this works on the principle of total internal reflection, which deals with light, whatever must be channeled, whether voice calls or data, okay, data is transmitted in the form of light in order to follow the principle of operation of this. But as to how it is modulated or bundled and demodulated, leave it for them. It is not your problem. Is that okay? Now, so this is how, now the advantage of this over the copper wire is that, you see, because the information is bundled in the form of light, it travels at a very fast pace. And the other advantage is that you can put a lot of information on this to be propagated compared to the traditional cable, copper wires that is used within the community. So large volume of information or voice calls can be transmitted over fiber cable and can be delivered within a short time because of the speed of light. Okay, then let me write some of the advantages. So large volume of voice and data can be transmitted and propagated, transmitted, and sent within a short period. That is one advantage of using fiber cables over copper wire. Then the other advantage is that there are minimal losses compared to copper wire. Minimal because no machine is 100% efficient. There is minimal, or let me see, there are minimal losses compared to the usage of copper wire or cables. Then the third advantage is that crosstalk is eliminated. What is crosstalk? I don't know if you've been on the phone while somebody's call also comes into your phone before. And this happens mostly in the house LAN cables. You'll be talking to somebody on phone and another phone call will just come in, and then you will hear people talking within your set. I don't know if you've experienced that before. Have you? Class?
No.
Okay, that is what
Yes, sir.
crosstalk. A call can cross you, okay? And crosstalk is so much it's on right whenever you use copper wires for transmission, propagation of information from one end. But Julian,
Please, is the crosstalk different from conference, like call or something?
oh yes, that's different. As for conference calling, it's a deliberate thing. Okay. But here it mostly occurs on household phones, the landlines, where you be talking to somebody on phone and another call will just come in. People will be speaking, okay, within. That is very, very right when the signal propagation is done using copper wires. But for fiber cables, it can easily be eliminated. Okay, so crosstalk is eliminated in the use of fiber cables. Now, the problem fiber cable usage often encounters is that navigation of ships can destroy the bundled copper wire fiber cables. It happened, I think, somewhere last year where MTN data was disrupted for almost a whole week or two. There wasn't any MTN data because the fiber cables laid within the sea was damaged by a ship. I don't know if you heard that or you were not born. Yes, it happened last year. So engineers had to dive and then repair the damaged cable. Okay. Then total internal reflection is also used in the health sector, the medical field. How is that used? The principle of total internal reflection is used to assess human body parts that is not easily accessible. Example, if you have problem in your throat, You don't expect doctors to cut your throat before, no. By the time they repair it, you are gone. So they sometimes also use this principle of total internal reflection to assess or look at parts of the body that is not directly accessible. And an example of that is in endoscopy. I don't know if you've had endoscopy before. Endoscopy. Endoscopy. I have. Now, what happened was that I had that feeling of something within my throat. So 37, they had to just look at the trachea or the canal to see whatever. So I was booked, and on the day I was made to just lie on a board. Then something was inserted within my throat and was being monitored on a screen. So that thing which was inserted within my throat illuminated lights, okay, through the canal, and it is being followed by the display of it on a monitor. In fact, when I was going, I felt, as for this, because I'm a physics person, I'm going to look at whatever is in there. So, but unfortunately for me, when the thing was inserted, the uneasiness or how the thing was never made me feel comfortable to even watch the monitor. only to finish and was told that there is nothing in my throat. Say, so that is endoscopy. Okay, so that is how total internal reflection is also utilized in the medical field. It is used to, look at inaccessible body parts. So I've made mention of in the communication and then in the health and medical field, okay, to examine inaccessible body parts, such as in the process in endoscopy and all that. Then another application of total internal reflection is by the use of prism periscope. Prism periscope. Please, we have mirror periscopes. Here I'm talking about prism periscope. Prism periscope. In prism periscope, triangular prism, two triangular prism or right angle triangle prism is arranged in this manner. Light is incidented at an angle greater than the critical angle of glass. Critical angle of glass approximately 42. So when you incident, this is the normal. When you incident light at 45, angle of incidence is greater than the critical angle, and the light will be internally reflected. So incidence reflected. Now, the reflected light, which is now incident light to prism 2, also incident at 45, and it will be also internally reflected at the same angle. So an observer here will be able to see something above, okay, above him or her whilst watching below. Okay, so the prism periscope also works on the principle of total internal reflection, and this is by using right-angled prisms or right angle triangle prisms. Okay, so this is another application of it. And then total internal reflection is also applied in binoculars. 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 It is also, you see, binoculars are these optical devices that is used to view objects at a distance. So the binoculars have the ability to bring objects that are far to clarity. So it is mostly used in the war movies and documentaries where tourists, okay, will be, watching through to have a better view of stuffs around. So it also works on the principle of total internal reflection. Then total internal reflection is also applied in the formation of mirage. In the formation of mirage. Please, do you know what a mirage is? Do we know what a mirage is? Can somebody tell us if you have an idea? Julian, Rachel, any idea of what a mirage is? Sorry. Amia, Nana Kwame, Tafu, do you have an idea?
Yeah, please, is something like an illusion, kind of something like that.
Come again. Is that
something like an illusion?
Exactly.
Or like
it's an illusion. Mamia, what do you have to say?
When the sun rays create an illusion that there's water ahead.
Exactly. So usually on a very scorching afternoons, when you walk on the road and then you look ahead, it always appears as if there is a pool of water ahead of you. You drive, walk, and you will never catch it. As you go closer, it also moves away further. That formation of that optical illusion, which is formed on a road during hot afternoons, is what it's termed as a mirage, and it is formed as a result of total internal reflection. I'll explain formation of mirage in our next meeting. Then total internal reflection is also what accounts for the sparkling of diamond. The sparkling of diamond. Sparkling of diamond. So I've made mention of a lot of applications of total internal reflection. Okay. I've mentioned a lot of them. From fiber optic communication as used by the telcos. I've also made mention of it being used in the medical and then the health sector. Okay, as in endoscopy. Then the usage of it in prison periscopes. Then binocular vision in binoculars. In mirage formation, in the sparkling of diamond, and then lastly, in the fish eye view. The fish eye view. Fishes can see 360 above, okay, around themselves, but 180 above and then 180 below. The 180 below is as a result of total internal reflection, which I'll explain to you. So these are some of the applications of total internal reflections. I'll look for questions on applying the concept of total internal reflection to solve problems. Then I go into some of these applications. Then we move on to the next thing. Please, is there any question to ask? Any further explanation? Is there any question to ask? Please, I want you see the set of questions I gave you. Review it at your free time, pick them, okay? Try and then solve it on your own and let the solution I gave you be your guide. When you hit the rock, then you come back to review whatever we discussed during the class and it will help you, okay? So don't just drop it, attempt it again and then see how you can apply, okay? By doing that, in fact, it will stick better on your mind. So if you don't have anything to ask, then this is why we draw the curtains on our meeting today. Okay, thanks for joining. Take care of yourselves and we'll continue tomorrow at 12. Until then, bye-bye.
Bye. Please have a nice day.
Same to you.